I appreciate your time.
My name is Heidi Fritz Martinez. I own a company called Remotor America, which is designed to promote American products and also connect global access to energy efficiency. I was part of a collaborative effort to do about $30 million worth of energy incentives, specifically for variable frequency drives. And I'm happy to help any way that I'm needed. So feel free to reach out to me anytime. Thank you all for coming.
Thanks for having us. My name is Derek Earp. I'm a facility engineer in Cambridge, Boston area. And I work mostly with the controls and automation and helping companies.
Thanks for coming. Good to talk to you again.
You too. Thanks for having me.
Hi, my name is Thomas Tran. I work for facility maintenance I work for American University as a facility maintenance technician. I'm here to try to learn and learning more about the VFD.
Thank you so much, Thomas, for coming.
Well, we'll go ahead and get started. Let's see. One opportunity is that if you'd like to join this group, it's actually Nikola Tesla's collaborations. There's about 2,500 people in there so far. I strongly appreciated what Tesla brought to the world, which is the electric motor. My family has been in this since 1953. My father and 6 of his brothers all started motor rebuilding companies back in the 50s. Still 7 of them exist in the Midwest, rebuilding motors for power plants, schools, hospitals, a lot of irrigation, agriculture. I've done a lot of studying. My schooling and stuff brought me to a mentor of mine, actually Curtis Reed, who was what used to be an RCA engineer out of Chicago. He took me aside when I went to college and he taught me a lot about Tesla. And I also studied a lot about AC-DC machines, synchronous motors, various types of motors. And so that career, being around my father, then being in various businesses across the United States. I've been from, I live in California now, but I've lived in Northern California, Southern California, lived in Boston for 25 years. And now I'm involved back in California again. I'm turned 65 this year, and I really decided I wanted to give back to this industry what has given me so much as far as, happiness, a lot of friends. My father used to be a chapter president of ESA, which is Electrical Apparatus Service Association out of St. Louis. There's about 2,500 companies in the United States that all share, collaborate information. So from that, we'll jump in here. And this fellow is, one of my mentors, so I just wanted to play a little bit who he was.
When you think of electricity, you think of Edison. But there is one electrical genius who is nearly forgotten. A man who dreamed of giving the world an unlimited supply of energy. His name was Nikola Tesla. This is the story of a modern Prometheus who changed the world with electricity. It was Nikola Tesla who captured the power of Niagara Falls with his alternating current system and made it possible to transmit electricity to all of America and the world. Suddenly knew he could recreate this rotating field by powering the coils of a motor in different steps or phases, like the pistons of an engine. The resulting forces of magnetic attraction and repulsion would literally twist the rotor in a circle, the electrical equivalent of the wheel. And all this was accomplished with alternating currents. It would soon turn the wheels of industry around the world. Tesla was ready to unveil his motor to the world.
The subject which I now have the pleasure of bringing to your notice is a novel motor which I am confident will at once establish the superior adaptability of alternating currents.
When
So the reason I bring him up is that the alternating current machine that exists out there is a fixed speed machine, pretty much fixed power, how much it draws. And so what we literally have is we have hundreds of thousands of electric motors, running every day in America and around the world that are pretty much set volume of how much they're going to use and pull, even though the loading requirements vary, but they really can't adjust. So there's said there'd be like, taking your car and, going around town, putting it at 1800 RPM and then using the brake to stop it. That's the way the electric motor operates. So it consumes a lot of power. And it ends up being about 70% of the power that the world uses, which a lot of people, may or may not know that, or they try to go, well, I'm putting in lighting, so we're getting efficiency. Well, lighting most of the time is only about 10% of the total load, in a factory. And so it's kind of minuscule of how much they're really going to save. A lot of times they'll put it in and they'll put in new lighting, they won't see much change in their power bill. Where when you put it on electric motors properly applied, it does have a very large impact. So where power is used on motors is a lot of it, about 51% of it goes to motion, conveyors, crushers, big applications, steel mills, those kind of things. 19% is in the HVAC industry, fans, pumps, compressors. And lighting is about 16% of our power, and 14% of it is other electronics and light IT equipment, which we can't really do much about the electronics and IT requirements. Lighting we can do, but there have been a lot of light bulbs changed in the last several years. And so that's kind of been tapped out for conservation. Quite a bit of HVAC was done in certain areas where there were rebate incentives, but a lot of it still isn't. Or they kind of had a cap, like in New York, where they would do projects, anything down to about 20 horsepower. And they thought, well, about 20 horsepower didn't really matter. Cost of equipment back then was kind of expensive. That goes back 20 years ago. Nowadays, they're going all the way down to quarter horsepower. They're even putting it on what they call EMC motors, which are directly onto, real small motors. But the main impact in HVAC is the chillers, the fans, the pumps, those big chiller compressors. Those need to be evaluated if they don't have drive controls to put them in. And then on the motion side, there's a lot of energy you saved also for other reasons. By just slowing a conveyor down, you really didn't need to move the material quite that fast, or maybe it's a press machine that has variable hydraulics. Those are opportunities. Like Heidi said, we were hired, or I was specifically hired back in the 90s to go to Massachusetts and do work for Milton Bradley Toys, Hasbro Games, all on plastic press machines. Then it rolled out from there. It went into schools, hospitals, ice rinks, buildings, and we did find, by doing all these pilot studies, a tremendous amount of energy opportunities. I also was involved with EPRI, the Electrical Power Research Institute, which documented many applications. There's information on the Department of Energy about VFD technologies. but there still seems to be a lack of motors being, retrofitted. I think the studies are today maybe 15, maybe 10% of the motors in America have been retrofitted properly. As compared to Europe, they're in the 50s and 60% range. Part of it is because power was more expensive there. Well, now that power is going up, it's definitely a point of big interest. And the thing that this slide's a little bit dated, but an example of a 15 horsepower motor, costs $450. Now it's almost, $750, $800. But if it ran 12 hours a day, 6 days a week, 48 weeks a year, this is back even 11-cent kilowatt. A lot of times we're now sitting at almost 22 cents. Over 10 years, that equated to the motor utilized $45,000 worth of power. Now it's more around 70 or 80,000. So the incremental cost of a motor is one piece. It's only about 1% of the purchase price. And if they didn't put a VFD on, more than likely it's not really controlled or balanced. And that's something we really push with the Tesla concept, is that, he was all about frequency and power. And, it's basically correctly providing the motor frequency and voltage to the motor that balances its actual load. And it also then corrects the motor to get all balanced power on all three phases. At 7 this morning, we actually had another class, it's kind of a little bit more advanced class. It was talking about, power quality, VFDs, various, do's and don'ts, and, how the structure of the machine is actually built, how a VFD is built, what the component parts are. We'll be having that class again. Plus, if you look at our website, you'll see we're going to start posting the actual video, so you can go there, look up the different area that you're interested in, put it back. Again, my point is to start passing this information along. It was actually developed by a guy named Nolan in the 60s and 70s, where he developed the soft start, then developed the frequency drive, for NASA. Then it rolled out in the later 70s, where Toshiba, who built the transistors in Houston, started building the regular VFDs, and then it rolled out from there over time. Back then, sometimes they were about the size of a phone booth. Now they're like maybe an eighth of the physical size. A lot of VFDs now are starter replacements, DIN rail mountable, easy to put in, relatively easily to program. We give programming classes for people to understand how to program them easy, what the key components are to watch for, as you are putting them in and starting them up, and what the value of, why and where to put them properly. So variable frequency defined basically is it's a electronic package when connected to a motor is capable of controlling the speed and power to that motor. They're a package design. Some people don't realize an uninterruptible power supply is basically a hybrid VFD that they're using. It's just fixed frequency output, but they're able to regulate and make sure that power is steady. And then they use DC batteries sometimes on the DC bus circuit to regulate. So even if the power is fluctuating out there, it always has the DC to still build the output correctly. Let's see, and it basically, controls the torque and the speed of the motor. AC power and DC power, the difference between, what basically Edison was a DC guy and Tesla was the AC guy, and Tesla's the one that won out for Niagara Falls to put it in. So again, you've got these rotating fields here that was shown in the video there, and they literally, because of the sine wave, will trigger when the north and south pole functions on that coil. From that, as we speed up and slow down this frequency and voltage amplitude, we're able to control that AC motor, which before was not able to be done. And that's the nuts and bolts of what we're doing. But then when you do that, you get the, the advantage. And then the difference between this shows a single phase set of coils on a 4-pole machine, where this actually shows all the sine waves of a 3-phase power. So when you have 3 power lines, feeding to the motor. One other point is that you can actually take a single phase input and drive a full develop, because we're doing it from DC, we can develop full 3-phase variable, going out to the motor. So there's advantages of savings there, because a single phase motor is about 65 to 70% efficient. A 3-phase motor is up in the 90s. And you have normally about a 1.5 to 2% loss in a VFD in its components, but the energy savings and balancing of power, definitely correct for, efficiency gains. So this is just a little bit what we talked about earlier this morning is, the basic structure where you bring in the AC power here, convert it to DC power. Capacitor is just to filter it to make the DC very smooth. You got a coil inductor in here. They call it a link choke to actually just basically slow down a capacitive in a circuit, so it the current doesn't rush and surge. That's what that's there for. And then it goes through transistors to rebuild with PWM back out to the motor, and then it gives you your current waveform. Why use it? Reduce electricity costs, up to 70%, especially on very lightly loaded motors or fans and pumps because of the cube law. It increases motor equipment and life, because you're unloading. Some of the facilities we've done on plastic processing, we've taken a 2,500 amp service, and after we put drive controls on a majority of the motors on that system, ended up being around about 1,000 amps of current draw at the end. So it does have some big impact. Improves the process, controlling torque and speed and pumps and flows. It also takes a lot of decibel noise out. So we've actually seen, a lot of facilities that, don't require hearing, gear and stuff on, because it's brought the decibel level of the whole factory down. And then, there's also several types of utility incentives. There's also money out there that's called zero CapEx money from investment companies that you can access that allow you to implement projects. And there's evaluations before, after, what you're going to save, come to an understanding of what the savings are going to be, and verified. And then there's a shared savings program to just pay it off over 5 years. After 5 years, you own the equipment, but you get it to do it, zero CapEx. Let's see. So some of the areas we worked hard on is a lot of light commercial, fans, compressors, chillers, cooling tower pumps, vacuum pumps. We also did a lot of large commercial, the bigger exhaust fans, compressors. They have what they call fixed applications in a lot of these incentive programs to implement it, where it's kind of like Tylenol for a headache, Heidi calls it, where they know what the impact's going to be. They know how much savings is going to be, so they know how much deferred income, that they're going to see and get for incentives back from the Public Utility Commission. The power company does that for one reason, is they make money off of energy savings with the way their rate structure works. So that's why even in Massachusetts, there's about $500 million a year implemented for energy conservation in all segments. Variable speed drives have become a very large portion of that. We were 51% about 3 or 4 years ago of all of the, about 5 years ago, all of the different energy conservation modes. The drive controls made the biggest impact for bang for the buck. So the dollars, were very, very well used, and help. So we've worked on, a lot of manufacturing facilities, conveyors, different types of presses, extrusion machines, injection machines, large scale food and processing, oven, fans, blowers, bottling, mixers. We've done a lot of work for canneries, PepsiCo, Coca-Cola, different ones where they have actually implemented the technology, even on bottling plants that, build, 400 cans a minute. There's a lot of, fans, pumps, and those things. Been involved a lot of municipal business, water supply pumps. There's a lot of what they call Parco valves that are put in front of them to eliminate water hammer. When you put a drive control on, you can take that valve out and get those losses that are going across that head. Plus, you're able to stabilize the pressure and voltage, so you don't have to have pressure regulation valves. Also on the output, of the system, a lot of the type of exhaust fans, cooling tower fans, process chilling water. We did some processing machines where we put about 60 or 70 drives on molding machines for an optical lens company, and we were able to take 300 tons of chiller off the roof, which they were using to cool the hydraulic oil chillers, and also cool down the building. A lot of compressors, both reciprocating, and both air and refrigeration compressors, balancing that out. There's a lot of them going in now on even rooftop air compressor or air conditioners, on both the fans, inlet fans, outlet fans, and the compressor itself, because we're able to balance, like the newer air conditioners that come out that have a VFD built into them. Most air conditioners for houses now do that. They actually regulate, getting the optimal point of that compression done, so they get the the proper amount of cooling out of them. And also even on big chillers, they've moved that quite heavily. We've been involved in big ones that were involved in Las Vegas, casinos. We've done them for schools, big locations that, again, the newer compressors are coming out with them, but we did some of the first pilot retrofits. We did ice rinks where we're putting on the chiller compressors to, freeze the ice. A lot of different pump stations. So the main factor is that, why they found that VFDs on fans and pumps were kind of their biggest hit at first, was because you get the cube law. So if you slow a motor down 20%, the actual horsepower of the motor, the flow only drops 20%, but the actual horsepower drops by the cube factor. It's called the affinity law. So the motor is 0.2 times 0.2, it comes out to roughly about a 50% horsepower reduction, not a 20-point horsepower reduction, similar to what you do when you put a vane on or a valve on. You get that extra savings by the VFD. You do have a 1 or 2% loss in the VFD, because you don't get anything for free. It does have a few losses in it, but the overall efficiency is quite dramatic. And what's happening in Europe is a lot of the motors now, they've also figured out that when you put a VFD on a regular induction motor, down at anything below 70%, the motor efficiency starts decaying. So as versely over there, they're in version 4 of premium efficient motors, where they actually have permanent magnet rotor motors on there. And we're actually being a lot involved in implementing new permanent magnet motors that's similar to what the EMC motors are. Those are a DC motor that's rectified power from AC with controllers and stuff on them. Again, because you get a better torque control of the motor after you get down there below 70%. And so you see about an extra 10-15%. They kind of overlooked it for a while, but every kilowatt counts. And so that's what they're starting to move forward. And Europe is pretty much standard. So is China and other parts of the country that are going that way. The historic way of changing power and speed was done with, belts, pulleys, fans, sprockets, gears. We used to have multi 2-speed motors. That's pretty much gone away, where they had, they would shift the motor in the windings, and that would do a lot. They used to have variable pitch pulleys, eddy current drives on a big bunch of pumps and stuff that were out there. And then, the implementation of the AC frequency drive. So they were controlling it by vanes, dampers. That's where, the typical, things that are in a building, regulation valves. So this was, the typical of doing that throttling on the output of the water pump, where now they actually, open up the valving, and then they control it with a VFD on a 50 horsepower motor. So, it does have a very big impact on, total power requirement. So this over 5 years, say about $4,000 a year in operating cost, and about $20,000 over 5 years. So it's definitely worked, dipping in. Plus you have your demand reduction because you're just not running up to that 19 kilowatt anymore. Let's see. So this is a sheet that talks about, variable torque loads, constant torque loads, and then constant horsepower loads, which are, these areas you really don't have too much opportunity. And what they mean by is like a machine tool, a lathe, milling, punch presses and those things. There's really not a way other than like on a punch press, you may want to slow it down to, slow the cycles down, but, that you really can't do much speed control in here. So it's got to stay constant horsepower. You don't see a lot of savings. But constant horsepower, constant torque power loads, by lowering the speed over, you do get more of a linear savings. And then like compressors, it depends on the type of compression it is. Conveyors, it's whether or not you can really, slow the conveyor down. Let's say it's to a rock plant or whatever. Printing presses and those things, again, the same thing. There's vacuum pumps and things in there that you need to take a look. Mixers, we've done a lot of work for various places that had mixing requirements. Again, back to what a constant torque load is, variable. And then let's see, we talked a little bit about this, the difference between, the flow comparison to with a VFD, the flow amounts, what the, fan curve is. One thing I do, we also have a class that's on pumping that we're going to give probably in about a month and a half, again, 2 months from now, which is basically, you got to be careful when you put it in that the pump everyone has a pump curve. And so there's a sweet spot on a pump where it was originally designed for, to run in a certain range and actually be at its optimal efficiency, up around 65–70% efficiency of the pump. Where if you go too far below or too far above, the curve goes off, and sometimes it'll dump per deck down to 30%. And so you forfeit some of your savings. So it's definitely important to do an analysis well before we start, where we're at on the pump curves, and also on the vanes and those kind of things. And it slows your ability to save. And then this is more of a, typical pump curve, with a VFD, but it just doesn't show in here. We have a software that actually shows where is the sweet spot to run the VFD in, so that you design it, you set your upper and lower limits so that they stay in that sweet spot of operation. These are the affinities laws. flow versus speed, which ends up being more 1-to-1. Your head to speed, is on more of a cube factor. And then you've got your horsepower to speed, which is on the cube factor. So it's, the head loss, meaning the amount of pressure it can produce, is about a 2-to-1 ratio, and a horsepower is at still a 3. So you can reduce it, still produce pretty good head pressure in your system, and achieve this. So it ends up being a combination of total power saved. These are, just some of the case studies that we were, over time involved in. This happened to be a municipal, or not municipal, this was a cleaning facility, dry cleaning outfit up near Lowell, Massachusetts, that we installed. The utility company, there was $31,000 worth of incentive available that we got. We're able to get $171,000 in annual savings. 12 cents a kilowatt ended up being, and this is the actual kilowatts amount, not the demand. There was some demand reduction, but we were talking specifically about kilowatt hours saved. And this ended up being about a 20,000 annual savings, about 102,000. And I think that was around about 30 or 40 drives installed there. This happened to be about a 1 million square foot facility. First walked in, they said, "Oh, we've got drives on." Yeah, they did, everything above 30 horsepower. About 100 motors later, found in the facility, incentives about 305,000, and had a couple $100,000 of annual savings. So it's definitely good. Heidi came up with a concept about being a motor hunter. They're all hidden in the walls in the back rooms, and people don't necessarily see them every day. They feel them, they feel the fans and the cooling going on in the building, but they don't necessarily do it. Or a production facility, I got to have that machine running. So they didn't go over. This would be a water supply facility. Implanted, and put it on several, the lift pumps, several of the booster stations. Again, they had some throttling going on, and then just balancing of getting, again, back to balancing the frequency, voltage, and power to demand, the facility. And the nice thing about controls today is they have a lot of unique software in them, so you can actually pre-program those properly to run, in those applications. Exhaust fans, ventilation upgrades, makeup air, again, on upgrading those. And these happen to be in some Midwest locations where the utility rate was much cheaper, than some of the coastal locations. What to do when you're going out and evaluating. You want to, look even deeper at the, the non-typical, because there may or may not be incentives on those. And, these are some of the questions we've had over different times we've given, things is, what's the drawback of installing VFD control? Most of them people say upfront cost. What's the real savings going to be over time? How do we get them commissioned, installed properly? Where do we find the right staff, get them done? Are my motors compatible? And how much timing are we going to lose, installing it? And then we've had other issues, but these are some of the biggest drawbacks. And, the upfront cost can be overcome by several of the application ways you can get funding. Again, Heidi has, Remoter America, where she has access, to about 35 states, plus we cover 100 of the state, or 100% of the states, also with the zero CapEx programs, where you can put the equipment in, so it eliminates that upfront cost. We also have ASRAE auditors available if need, where they can go in and review sites, look at them, get you the detail, and give a realistic view both to the CapEx funders and to you as the operationals of the buildings. And then we also then, help with making sure commissioning plan is done. And we're also here to answer questions. So I get a lot of calls every day from various people around the country that are, running into a problem or whatever. There seems to be less people going into the trades industry than there were, years ago. And so there's, kind of a loss. And so people kind of have a fear factor. We want to take that fear out because it literally can be install time. We've installed, hundreds and hundreds of drives, without very little shutdown time on a factory. It can then be all mounted, wire ready to go, and then, converted over in about 15, 20 minutes, properly programmed. So that's that part. So, we want to conduct the audit, get some flows and pressure information, projected, savings evaluations. We literally have thousands of locations that we've done and been involved around. And not from one vendor. It's not an issue about, trying to be sole vendor or sole supplier. That's not the point. Some people do have certain brands and stuff that they've, gone accustomed to. We have some access to those, or, we can get you some recommendation through this ESA organization of, where to find the right products, to get them, cost effectively. Get that pre-evaluation. And then also there's a lot of extra incentives sometimes to put it in where you can put in what they call measurement verification. So the drive controls have kilowatt hour meters, most of them built in. So you can data log how much actual savings you're getting out of that machine, and bring it back to your BMS system, through various networks. They are compatible. Again, then, getting the compatibility correctly to the motor is really key. We really recommend people to take pictures of the nameplates, so that, a motor guy can actually look at it and see, okay, what was its design? What was its, amperage loads? There's been, application errors made because a 900 RPM motor at, 100 horsepower has this different amperage rating than a 900 or the same motor in a 1800 RPM motor. So, and you can't turn a 1800 RPM motor down to 900 RPM and get the same torque out. So it's important to understand the torque factors, especially, in more constant torque loads. But, we've ran into facilities where, they went to bid, looked at the application, got it all installed, everything was to spec or what it was, but somebody didn't look at the RPM ratings. And, now they literally cannot run those motors over 50 Hertz, or they'll trip out all the time. They just have too much amp draw, and, it caused a little grief. They're getting around it, but, it's not the best way to do it. These are some examples. These were medium voltage motors put in a power plant. These are about 750 horsepower. We put it on the draft fans in the middle there. And we put it on both the boiler feed, pump 1 and pump 2 in there, which feed the boiler water into the boilers, so that they could control that. There was a 10% service factor that they had to build in, that they could never go over that. Right. Well, they were able to, by regulate the speed up to about 62, 63 Hertz, they really get the extra amount of water that they really could use at the boiler. And it actually increased the output of the plant by almost another 0.5 megawatt. That simple adjustment, did it. And then by the time they put drives on all the other parts of the facility, they saw about another $500,000 worth of savings, just on all of the other ancillary fans, pumps, and stuff that it takes on a power plant. So we're giving a class, I think around the 15th or 20th of next month. It's on our website, that talks about those applications for power plants. We've also been involved in medium voltage facilities for 330 megawatt gas-fired plants. It's another way to get more power without having to build more generation out of existing equipment. We do highly recommend that you do, look at the quality of the drive controls. There are differences in drives, and one thing you can look at is the carrier frequency of where the motors, can operate at. Some really say you should never go over 4 or 5 kilohertz per wave. Well, the better ones, go up to 10, 12. And also that means that the transistor can fire faster and build a better waveform. You want to look at the construction, of the capacities. We don't sell variable torque drives. We really feel what a variable torque drive is actually a drive that is a constant torque, meaning 150% overload for 1 minute, derated to 125%. So they're able to put that on a 100 horsepower drive. They can put it on a 125 horsepower motor on a fan or pump. They get away with it most of the time, but the problem that you run into is if you get a lot of surging, that transistor is a little bit weaker. So my dad always told me, put a little bit more into it. It isn't very much more expense, but it sure does cost you a lot less downtime in the future. And most motors, especially in the pumping industry, tend to be ran in the service factor. So you want to make sure that the motor's in a good spot. See the type of enclosure that you're putting it in, whether it's got the controller is actually built. We have some controllers up to 120 horsepower you can put outside. They have ability for disconnect switches, put in the fuse protection and stuff required into them. We would recommend putting the high-speed fuses on the front of drives, not just circuit breakers. It improves the life, especially if you get a lot of surging power. Power quality is getting worse in America because of the various type of power sources we have now. It's not the old fixed generator. We got solar coming on and off different times of year, so they have to constantly transition and transmission shift on and off various parts of loads to balance that, and those imbalances could cause a lot of motor failure. And we talked about that this morning a little bit further, and you're welcome to watch that video when it comes out. Again, we've had implementation. I was involved in the Electrical Power Research Institute when they first did the evaluation in the 90s about upgrading injection molding machines. We actually brought a lot of that to market. That's why I ended up in Massachusetts. They brought me there to build Milton Bradley Toys and Hasbro Games in Rhode Island, and plus, thousands of other machines there and also around the country and even around the world. Today, it's pretty much a standard in the machine. But there's also, checks and balances. Those machines where you have a lot of high spiking power. So there's a lot of requirements as you install those and make sure that the drive is suitability for it. Drives create a soft start capability. Helps the original inertia into the motor. You get your peaking. Some are used for peaking load reduction, so you can literally take some parts of your load. You don't have to shut the machine clear down like your chillers and stuff. You can just drop them back to maybe 80%. It may raise the temperature in the building, but you can get some incentives back for that, for a facility. So we can help you with how they do that, where they're looking for, additional, peak shaving money, out there. Heidi, maybe you can jump in what you did for a couple of people of getting also from the state funding that you did.
Sure. Thank you for the time. I think that a lot of missed opportunity is connecting economic development and workforce development into the energy picture. So there was a situation in Massachusetts, I won't say the company name, but where they were only going to give him about $50,000 worth of incentive, but the project, including another project, was well over a couple million. And they refused to budge on it. It was, we don't really consider that a priority. It's too much money. And so in getting different state officials involved, they actually covered the entire project 100% between a combination of those monies. So sometimes in these things is you really have to be able to hold the customer's hand or figure out how to leverage the savings and what that means to the economy in which that that business is located in order to really help a lot more. And he ended up getting like a $750,000 molding machine that wasn't even part of our project. So I think raising awareness to that, you can't on the news say that climate change and all this stuff is a priority, and then on the other side, make it impossible for someone to participate in your program. So fortunately, since then, there's a lot of other programs you can take advantage of, and you don't ever have to have your power company's permission in order to save energy. So again, anytime I can be of help, please just reach out, and thank you for the time.
So the, potential issues with the VFD, you got your high initial cost. Well, that's where we feel even that is not what it was, back where some of this was written, actually back about, 7 years ago. VFD prices have dropped dramatically. Sometimes not so much in the United States. I don't know why, but there seems to be some propping up of prices or something compared to what's happening. We're partners with facilities in England, Italy, Germany. There's also a lot of people, oh, you can't get them right now in America. Well, there actually is access around the world that you can get them from. The ensuring the proper control strategy, so that they get installed, they get properly controlled to a sensor and or BMS system. We work hand in hand, both with the building management systems, and we work hand in hand with the controls. And at the end of the day, they can operate by their own. You got a pump running a pressure, regulation. It can all sit there and operate, without even having to be tied to a BMS system and still save the same amount of money. There's issues of concern when you get above a large number of drives about harmonics, because we talked about that earlier today on our other meeting. We go into more detail, as you get involved in this to how to get and scope and, pre-study a facility. It's becoming more and more issue across the country. We're working on a project up in Ohio, or I guess Michigan right now, for a facility, where they're getting hit with a $25,000 a month power factor and harmonic penalty, because the building, because of COVID, is not being fully loaded anymore. So the chillers are not running at the optimal point that they were originally designed for. They're all sliding off the curves, but the cost to try to change those chillers out is astronomical. So there are technologies out there that can go on the front and be active. They call active front end equipment that will clean it all up and give it all sinusoidal total back to the power company, which then they're happy. Their hybrid meters don't pick it up, and it cleans it up cost effectively. Again, how much can you turn it down to the suitable need? And then feedback controls. Most drive today's all have the, both 0 to 10, 4 to 20, PLC control input, so you can, program it up, to the actual application. Many of them, can go into the smart building integration systems, where they have BACnet, Profibus, DeviceNet. Let's see, a lot of them have easy programming. A lot of them are designed now where you have a zip drive where you can have a set of parameters for OneDrive, you got another repetitive one down room. You can just download the parameters in. Really cuts on time of startup. This happened to be on a facility up in Lowell area where you can see here, this was the loading factor of everything prior. And by the time we put in the BMS and drive controls, we end up seeing about a 45% reduction in their total power bill. So again, they have prescriptive incentives, like Heidi calls them, Tylenol for headache, or custom, which takes more data is all. And the better the data is pulled together of what the power company needs to go on in so that they can get their money back to the Public Utility Commission. It's just important that that detail gets done. We've done thousands of applications, both custom and prescriptive, to help people out. There's low voltage, up to 480, 575 volt. They consider low voltage. The 200 to 575 volt are all low voltage rated. We've also do medium voltage controls that go from 2300 volt up to clear up to 13K if you need, because they do build inverters that actually build power. They transmit power DC and then put inverters on the back end side. But majority of stuff we deal with is medium voltage, which is 4160 volt motors in America. Sometimes there's 6,000 volt overseas. And then the energy management system, there's also incentives to apply for there as a combo, to get the, again, get maximum incentives, get least amount out of pocket, to cut those utilities. Prescriptives, is the most common, pretty quick applications. They will give some incentives on new, but they really don't do too much for replacement, if one goes bad. Determine incentive amounts. So this is what the apps look like. They have different categories that we check off, fill out, and then these are the incentives. Incentives have pretty stayed much the same for these up through 150 horsepower, which today, on a 150 horsepower motor, $1,250 is still a very good incentive for that. The drive cost may cost you, 6,000 to 7,000. So but you got money for install. And we help people, choose some of the correct vendors and get that right. These are some useful resources for the Officer of Energy Efficiency, also Department of Energy, motor decision matters, which were for a lot of the original motor rebates. NEMA, down in Washington, DC, about combining. So, I want to thank you for attending. We like to keep these about an hour. We've gone about 55 minutes. I'd like though to please just open up questions. We'll stay here for a while, whatever you need, just answer questions as you need them. But we appreciate you attending. We will have the video available. We're set up a new system where the videos are going to go on to the website of one of our companies, AC-DC-HOTLINE, and it'll actually have an access to the Tesla videos that have gone on in the past. So you can, as you have time, you can be able to go back to the YouTubes, and see the various recordings and, listen to these classes we've done. I've given probably now already my career, hundreds and hundreds of these various seminars for both power companies, water companies, National Groundwater Association, Electrical Power Research, EPRI, the IEEE groups. Again, my father got me into this industry. I love the industry. I want to see it succeed. I want it to help save, power, create some of the, carbon, content that we're dealing with that, everybody's, worried about, which is, it definitely had some impact. Things have changed in climate some. I don't think we need to, be quite as worried about, some people think we are, but, the power cost of the amount of energy that's consumed by electric motors, can be controlled and stopped, slowed. As if you've got to go put up, wind turbines or sun or solar, systems to offshoot that power, you're still having a wasted energy. So you can, reduce your wind farm, reduce your solar intake, if you really control the source and getting it to optimal efficiency. So thank you again, and open it up for questions if you have any.
Hey, Roger.
Yeah.
This is John Jobaleski.
Hi, John.
Hi. So we had communicated a while ago in the past. I work for Aero Electronics. Are you guys looking for a distributor like Aero to be a distributor for your products?
Yeah, we are. We just want to have more people that can kind of train people. What we feel is, if you train people to become motor hunters, you teach them about some of the factors of how to put a VFD in properly.